So for as tedious as all the simplifying radicals and square roots and nth roots can be, there is a way to make it a little more practical, and it's going to help out as we move forward, and that is when we're going to take what are called rational exponents. And just think of that, remember that also is another way to say fraction. And sometimes you'll even hear people talk about fraction or fractional exponents and radicals, but it's a way to write a square root of something as a radical and vice versa. So these are a little bit redundant. 1 over n just means we're taking that root of the base. And so by the same extension, when it's m over n, see here n was our index. Here n is still the index, but now we're raising our base to some kind of power. Okay? So they're the same thing. This is just when m equals 1. Okay, so we're going to write 28 to the 1/2 power in radical form. 28 to the 1/2. So this is our index, so we're taking the square root of 28 to the 1st power. Okay, now square roots are common enough that we don't usually write it down, so I can just write the square root of 28. And when I simplify that, I'm going to multiply 4 times the square root of 7, because the square root of 4 is 2, and we've got 2 root 7. It's completely simplified. The conversion part happens here, and then I simplify that down to 2 root 7. Okay. Moving on to example 2. If I've got -8 over -125 all to the 1/3. Okay. Well, the first thing I'm going to pay attention to is that this is negative over negative. So I don't need those. So I'm going to rewrite 8 over 125 to the 1/3. Okay. And if we remember rules of exponents, that means I've actually got 8 to the 1/3 over 125 to the 1/3. Here's my index, and the 1 is my power. So the cube root of 8 to the 1st, the cube root of 125 to the 1st. Okay. So what number times itself 3 times is 8? I can rewrite this as the cube root of 2 cubed and the cube root of 5 cubed. So my cube root and my cube cancel each other out, and I'm left with 2 over 5. And last example, and this is where it really can help kind of make your life easier. So if we split this up, okay, maybe 144 to the 1/4 doesn't help you at all. That's okay. I'm going to leave the 4th root of 144 here, and then we're going to move over and take the 4th root of x to the 6th. This is where it gets nice, because the 4 is my index and the 6 is my power. So I can think of this as x to the 6 over 4. Okay. Which, when we simplify that, I get x to the 3/2. So all we really end up doing is changing this to the square root of x cubed. But this still isn't, the power in here is bigger. This is an improper fraction. This is an improper fraction. So let's back up a little bit and think about 6 over 4. That's the same thing as 1 and 2/4, or 1 and 1/2. That means I have one x that came out, and I'm left with x to the 1/2, or the square root of x. Okay. So now let's deal with the 144. I'm looking for some number to the 4th power to equal that 144 so that hopefully I can just clear these and it'll be fine. So if we start looking, 3 to the 4th. That's 81, it's not big enough. 4 to the 4th is 256. So between 3 and 4, it's already gotten too big. If I try to divide that out, 81 divided out of 144, it doesn't divide evenly, so I can't use it. So let's see what 2 to the 4th is. 16. Can I divide that out of 144? That works nicely. So we can take this 2 to the 4th, 4th root of 2 to the 4th, and the 4th root of 9, and this is 2 times the 4th root of 9. Okay. Now, again, if I think of this as 3 squared, then I can write 2 times 3 to the 2/4, which is the same thing as 1/2. And now I've got 2 square root of 3. Well, I've managed to simplify my index all the way down so that they're the same on both sides. So I'm going to take the 2 outside parts, 2x, and combine the square root of 3 and the square root of x, and we've completely simplified the 4th root of 144 x to the 6th.